In Chapter 7, we'll build on what you've already learned by walking through 3 different peptide examples that demonstrate how DIA complements and extends MS1 analysis. Here's what we'll cover. First, how clean MS1 data can still provide accurate deuteration results. Second, how deconvolution can resolve minor overlaps in MS1 with DIA adding valuable confirmation. And third, how DIA fragment analysis alone can salvage severely overlapped peptides that conventional MS1 software would exclude. By the end of this chapter, you'll see just how powerful DIA is in ensuring accurate peptide measurement across a range of real-world situations.
In cases where we have no overlap and the data is clean in MS1, then both conventional HDX MS1 software and HD Examiner Pro will have an easy time to figure out the duration of this peptide. So in this example, the target peptide is a 2+ at this mass. The data is clean, there are no overlaps. So that means that we can actually get an MS1 deuteration from the MS1 data, and any software should be able to do this. Now, in DIA mode, we do have this extra dimension of data that isn't available in conventional software, and that is just going to be used to endorse this MS1 measurement that is already pretty reliable. And that means that instead of a single measurement, we now have 15 extra deuteration measurements of the exact same thing, as you can see here on the linear trend. In the second example, we might have a minor overlap on our target peptide. And so in this case, the target peptide has an overlap on the 4th peak that's coming from a different peptide, just because the spectrum is quite busy in this mass range, it seems. And so MS1 could be resolved if the software is able to deconvolve this extra signal that's coming from the overlap. In this case, HD Examiner Pro can do that. It's fitting a binomial distribution to the data, and it's using the peaks that it finds that it thinks are not overlapped in this case. And other software in this space can do this on MS1 data alone, so you could get the accurate deuteration measurement if deconvolution is provided on the MS1 spectrum. However, for DIA data, again, we are able to get these extra measurements that come from our fragments. And so the MS2 deuteration in this case can be used to endorse the deconvolved MS1 deuteration, or in cases where it can't deconvolve the signal here, then it'll be used to override the MS1 deuteration with the measurements coming from the fragment space. In the third example, we have a significantly overlapped peptide. This is an example that I've used previously to show how MS2 data can be used to rescue MS1 data. In this case, this peptide would have to be deleted in conventional HDX software because the overlap coming from a 3+ peptide is completely compromising this peptide's 3rd, 5th, and 7th isotope. And because it's got these overlaps, if we were to measure the experimental data here, it would give us an incorrect deuteration measurement. And so that means that we have to only use the MS2 data to get the deuteration measurement here. And you can see here that the MS2 data does fit a nice linear trend. With the barely deconvolved peptide, here it was deconvolved by deselecting some of the overlap peaks. But in the end, it's still that the correct deuteration measurement was still able to be provided by the MS2 data alone. And these are done via 12 extra deuteration measurements from MS2 space.
Up next, in Chapter 8, we'll take a closer look at how DIA strengthens data quality across complex protein systems, and why it represents a more reliable path forward for high-confidence HDX studies.